All right, let's go ahead and get started. So welcome to today's webinar presentation, How Mobile Game Cheats Unlock App Security Lessons, brought to you by Guardsquare. I would like to introduce you to our presenter, Jan Serendinsky. Jan is a mobile security researcher and pen tester who also has over 5 years of experience in mobile app development. He has advised the top UK banks on secure architecture and anti-tampering techniques. Having reverse engineered and analyzed over 1,300 apps, he gave a presentation at R2Con on the current state of runtime application self-protection. At this time, I'd like to do a quick sound check for Jan. So Jan, please say hello to our audience. And audience, let me know if you can hear him by posting a message into the panel.
Hello.
Okay, awesome. Looks like we're good to go. And now I'd like to pass it off to Jan for the presentation.
Yep. Hello. So let's start from the top. My name is Jan Serednicki, and I will talk about cheating in mobile games and how the same cheats can be reused in regular apps. I will show you some popular attack techniques that attackers use, and also those that allows them to actually walk through walls. So let's start from a short demo about Among Us. That is quite a popular app, so I hope you all know that one pretty well. So here we are the player, here the red one, and normally in that game we are not able to go through the wall, but I will show you actually how easy it is to walk through the walls. But firstly, we just need to switch into a ghost. And once we are a ghost, we can actually go through the wall all the way to the left side. And once we are on the left side, we can just switch back into being a human and continue with the game. And it's easy as that. You just need to switch into a ghost. I will tell you later on how to actually do that trick. Apart from that, I will also show you a few other attack techniques that attackers use. Like for example, I'll show you how hackers bypass payment screen and Touch ID screens, so they can, for example, bypass those in-app purchases. Then I will talk about downloading paid apps for free, because, well, there are more app stores than only the original one. There are a lot of alternative and third-party stores where you can get the same app just for free. And it's not only about App Store, the same applies to Google Play as well. Then I will cover unlocking premium features. So a lot of apps that are in third-party stores, they are also tweaked and modified. So they have some premium features unlocked or some more stuff. Then I will also cover how to modify the number of diamonds in some games just by modifying the memory directly. And later on, I will show you how to protect against all of those attack techniques just by following 4 simple guidelines. Those are environment integrity, application integrity, code integrity, and obfuscation. So let's start from getting diamonds for free, and I will show it based on Tamagotchi example. So Tamagotchi was quite a popular app in 2020. I believe it was in top 20 apps in App Store and Google Play. And in that game, you have diamonds, and diamonds is a premium currency. You just need to buy it with your real money. So let's get into a demo. Let's open the Tamagotchi app. And here you can see that right now we have 1,478 diamonds. And in a second, we will change it into a way more. But firstly, a little proof that we actually need to pay for diamonds, and they aren't really cheap, actually. So let's close the app and let's enable a memory scanner for Tamagotchi and open back Tamagotchi app. And in here, we will see a red pop-up like that one. That is actually the memory scanner overlay. So we can tap on it at any time during the game and scan the memory for a certain value. And we will scan for an integer of 1478 because that's our current number of diamonds. So we tap on that gear, we open the memory scanner, and right now we are typing the number of diamonds that we have right now. We scan the whole memory for those variables, and you can see that there are more variables with that integer than only one. So let's try to filter out which variable actually describes the number of diamonds that we have right now. So let's buy something for 1 diamond. And in Tamagotchi, you can buy a sushi, for example, for 1 diamond. And let's filter out all of the variables inside the memory. And we can see that only the first number has actually changed. Well, it decreased by 1. So we can see that's actually our number of diamonds, and the rest variables are different. So we can just modify that variable by tapping on that address and by typing any value that we really want. And right now, we have overwritten that memory with our own value, and the number of diamonds has changed. Well, actually, here you can see the old value, but the graphic user interface hasn't changed yet, hasn't refreshed yet. So let's close the app and open it again. So the graphic will get refreshed. And you will see on the top in a second that the number of diamonds has changed. So right now we have 7,777 diamonds. And well, we just changed it without paying for those. And as you've seen, we actually didn't we didn't need any hacker knowledge. We just used a tool to scan the memory, look for our diamonds. We overwritten the integer, and that's it. Like super simple, and you can do it the same trick even today after the webinar. And you can also do it on Android. So before I tell you how that one works, I will show you one more example because they are very similar in the way they work. So here we have another app, and inside that app we have a lot of ads. For example, here is the one on the top left corner, then another one on the bottom. So, well, we just want to remove them, and we can remove them by tapping here on that button with crossed ads text. So let's tap on it, and we will see a payment pop-up. It asks us to pay to actually remove ads. Well, obviously, hackers don't pay for that kind of stuff, and I will show you the trick to actually do it yourself. So we attach to the application, and here we will just invoke a function inside the application. So we will just invoke onTransactionSucceed function. That function is invoked after a successful payment. So if we paid for that feature by tapping with our finger on the scanner, that function would be invoked. But we can invoke it right now when we are attached, and we will just later on tap on cancel so we don't have to pay it in real life. We just invoked that function, we tap on cancel, we restart the app, and you will see in a second that there are no more ads here. There is no ad here, no ad here, and that button also disappeared. So we actually paid for removing ads without paying for it just by invoking the right handler that would be invoked after a successful payment. Also, it's worth to mention that you can bypass Touch ID screens in the same way. And obviously, the technique also works for Android. So right now, let's talk why those techniques actually work. And they worked because our environment, our operating system was compromised. And protecting against compromised system is called environment integrity. And environment integrity checks whether the phone, for example, iPhone is jailbroken or an Android device is rooted. It also checks if an app is running inside an emulator or maybe the whole system is running inside an emulator. Well, it can also check for the presence of debugger, for example. And if we don't implement environment integrity, then an attacker can invoke any function of his choice inside our application, as we did with, for example, bypassing payments. Or an attacker can, for example, scan the memory and look for variables he needs and then modify them. Or what's even, I think, worse, an attacker could install some hacking tools on a jailbroken or rooted device, and then they can install a memory scanner, as we did, and just hack the app in a very, very easy way, as we did in Tamagotchi example. So a lot of companies were actually victim of that kind of attack. And well, one example is about a leaderboard ranking system where attackers just invoked some functions to just go up into the ranking system. So they were just better than their peers online. So right now, let's talk how you can protect your app on your own. Firstly, a jailbroken device or a compromised device leaves a lot of footprints inside the file system. For example, bash binary can be found on iOS, or SU can be found on Android. Well, there are way more files like that, and for sure you can find at least 20 more online. But if you use those two, it will be for sure enough for a basic protection. Then you can also check for applications that are installed on the system. For example, on a jailbroken iOS, you can find Cydia, and Cydia registers an URL scheme inside the system. So from your application, you can just check if that URL is registered. And if it is, it means that Cydia is installed. On Android, it looks a bit similar, but on Android, you just ask a package manager to list all of the packages in Android, and then you can just check if there is Magisk, which is quite a popular app found on rooted devices. Then you can also check for process properties. So on iOS, every app has a set of flags, and they are present only in runtime, and they are maintained by the operating system. And normally, an app should have CS-kill flag and CS-hard enabled. And on jailbroken devices, you can see that those flags are missing. So you can easily check it by invoking CSOps function and verifying if those flags are present. It looks a bit different on Android, but there is also a way to check for properties. You can check if debugging is enabled for the system-wide operations. So if there is a debugging enabled for any app inside Android, then you can be sure that you're running on a rooted Android device. Another way is to check for the emulator. On Android, you can just check the name of the device that you are currently running on with your app. And if that name contains emulator string, it means that, well, you're probably running on a simulator. If you want to get some more advanced protection, you can use NDK on Android and use some rarely known instructions. So not all of the instructions are implemented on emulators as they are on normal processors. So you can just compare behavior of your application when they execute those instructions. For more checks, I recommend going into OWASP MSTG. They have a few more examples for your app. So now we go to a different topic. We will talk about installing paid applications for free. So as I mentioned before, there are more app stores than only the original one, and more Google Plays than only original one. And in original App Store, you need to pay for a lot of applications. But if you want to get that app for free, you can just get to a third-party store, which is also known as alternative store, and get it from there. And those apps are totally the same as the ones from App Store. They are just made free for anyone. And there are quite a lot of such alternative stores online. Now I will show you how it actually works. So an attacker can install a paid app. He would just pay for it once. He would install it on his device, and then he would download the IPA file on iOS or APK file for Android. They would download those files to their computers, and then they can, for example, share the APK file with their friends or distribute it online. So once the attacker has an APK file, they can do actually anything with that one. They can just upload it online and make it available for anyone for free. For example, they can upload it to a third-party store and just make it out of charge for anyone. But they can do way more than making them free. They can, for example, modify some resources. So once they have an APK file, they can unzip it and change something inside. So for example, there is a game where the map are defined inside a JSON file. And you can see on the bottom left corner, for example, the number 174 inside data array. So 174 is actually the river. So if you compare those, if you compare the shape of those numbers with the shape here on the map, it's similar. And we can just modify the JSON file in a way we actually want. So we can, for example, change it into a huge G letter. We can actually modify it in any way we want. And then the map will be the same as we compiled it. And what's more, we can also use it in many different ways. For example, if there is a monster that we cannot win with, we can just remove it from the map just by replacing one number with another inside a JSON file. Right now, I will tell you how it works exactly. So firstly, we download the APK or IPA file, and then we can just unzip it because an APK file is just actually a zip archive, the same for IPA on iOS. And in there, we can just browse through directories and find those maps, and they are just merely JSON files. So we can just open it and we can edit it as we did on the slide before. So firstly, we can modify those resources, or we can even add new resources. We could just add new maps here. Oops, sorry. And also we could inject the whole new dynamic libraries. But what's more important here, if we inject new dynamic library, then we just inject the whole new code. So an attacker can inject not only new maps, for example, but new functionality to the game, which actually can get scary later on. And now I'll tell you why. But firstly, protecting against those kinds of attacks is called application integrity. And application integrity is about verifying whether app resources aren't changed. So for example, if JSON files are the same, if no one changed them, we should just check for it in the runtime. We can, well, application integrity is also about verifying if the app is installed from a legitimate source. So for example, from App Store or from Google Play. And there are many ways to actually check for it. And I will cover it in another slide, the next slide. So if we don't implement application integrity, an attacker can, for example, redistribute our app for free. And he can even put some built-in cheats in there, or modify assets, or even add new assets to it. Also, as I mentioned before, an attacker could add a new dynamic library with hidden malware. Another important thing here is that an attacker could repackage our app in a way that would allow to attach debuggers to it. And if we can if we can attach a debugger, we could actually imitate a compromised system. So we could invoke any function inside our app or scan the memory and overwrite any value, as we did in those two demos in the beginning of the webinar. And there is also a very common false belief that we can only hack applications on jailbroken or rooted devices, which is not true. We just need to repackage our app and repackage it in a way that allows us to debug the application. Then we can just invoke any function of our choice and do anything as we did in a compromised environment. And so a lot of apps were actually victims of that kind of attacks. For example, Duolingo and Mimo, quite popular apps, they were repackaged with new courses inside. So there are, for example, some paid courses or courses that you need to unlock. But an attacker can just repackage the app with new courses and made it available for everyone for free. Then also there are applications that were paid in App Store or in Google Play, but if you download them from a third-party store, they are just for free. Now I will tell you how to protect against those kind of attacks. So on iOS and on Android, we can just check the signature of an APK or IPA. So we can verify if the package name of our app has changed in the runtime. So an attacker needs to repackage the application. Once he repackages the application, our package name, well, the package name of the application will probably differ. It has to differ in many cases. So we should check for it in the runtime if it matches ours. But we could also check if the certificate with which we signed the application belongs to us. And we should also do it in the runtime to compare those signatures. Then we can check some files in our package. So for example, we can check a JSON file that was describing our map in a game. We can just create a hash of it, just a checksum hash, a simple SHA would do here. In case of Android, we can go into meta-inf directory, and in there you can find all of the hashes for all of the files inside the Android package. So you just get it for free. You just need to go there and compare those hashes in the runtime. Then you should also check if your application is debugged or is debuggable. On iOS, you can use ptrace. So if your application is being debugged right now and you use ptrace, the application will crash immediately. So, well, attaching with a debugger wouldn't be possible then because it would crash at a time. Then we can also check for the parent PID. So anytime you open an application from the menu, then the parent PID of the process is always equal to 1. If it's different than 1, it's actually opened by a debugger. So always make sure that your app is started from the main menu. Also, we can check for the system properties, and if in there is a CS debug flag, it means that our app is being debugged right now. On Android, it looks a bit different. So we can check inside Android manifest.xml whether the debuggable flag is set to true. If it's set to true, then it means that someone can just debug our application. And we can also use debug.isDebugger connected to check whether our application is being debugged right now. And that whole check is quite important because we can protect against all of the issues that we would have with compromised system. Then, well, for more solutions to protect your app, I recommend going to Avast MSTG. But for sure, if you use the ones from the screen, will be enough for basic protection of your app. Now we go to the third topic about unlocking premium content inside apps. So if we download apps from those third-party stores, they are often modified. So in case of, for example, Bloons TD, we can see that the application is a bit tweaked in a way that there is unlimited amount of money, or all costumes are unlocked, or all heroes or towers are unlocked. So not only applications can be installed for free, but also they can be tweaked in a way that would give us advantage over other players. But it's not only about games, it's also about regular applications. They are also tweaked in a way that you have premium account, or some locked courses are now unlocked. Okay, so let's go to the next slide. And here I will show you how to actually those hacks work. So let's say that we have our app and we check the license inside that app. And from our developer's perspective, it looks like a few lines of code. Here we have a function. We check for the license. Then inside we have isValid variable. It's set to false by default. Then we invoke validate license on server. And if it returns true, we just assign true into isValid, and then we return. And from the hacker's perspective, it looks a bit different. So the attacker doesn't see Swift code or Objective-C code or Java or Kotlin, nothing like that. An attacker can see assembly or Java bytecodes. And well, but still, you don't need to know all of the instructions here, because well, it's actually super easy to bypass that check. So here, if you look at that red arrow on the right side, you can see a TPZ instruction, and TPZ instruction is just if statement in assembly word. So TPZ instruction checks if the return value is 0. So one instruction before, we just invoked validate license on server, and then it returned value. And right now we check the return value with TPZ instruction. And if that instruction, if the return value is true, then we just take the left branch, because true is like 1 in the binary word. So it's not 0. So we just take the left branch here, and we can see that here we just assign true into isValid variable. So we can just easily spot that if you have an if statement we can just see another block like that, and everything what's inside that block is actually inside that closure for the if statement. And we can, sorry for that, we can easily modify the TBZ instruction to actually reverse our if statement. So let's have a look on the bottom left corner here. Right now, we are checking if the return value is 0 with TBZ instruction, but we can modify the TBZ instruction into TBNZ, and it will check if the return value is not 0, which will just reverse our if statement. So then anytime we actually check the license, it can return false. And here we will always get our license validated correctly. So protecting against those kinds of attacks is called code integrity. And it is about verifying whether the machine code or Java instructions aren't changed. And if we don't implement code integrity, an attacker could, for example, unlock premium content, as we unlocked the check license check, or an attacker could remove ads or make currency unlimited for the users, or even bypass whole authorization screens. And well, there are many apps that were actually victims of that kind of attacks. We have talked about Duolingo so far, so let's maybe talk about Typorama right now. And that app, for example, generally that app modifies images. It, for example, adds some text on it, but you need to pay additionally for certain features. And that app was tweaked in a way that all of those filters, all of those new features are unlocked without paying. So, well, now it's probably huge loss of revenue for those vendors. And there are way more apps like those with a lot of different hacked features in there. So how to protect your app against it on your own? So here we have our check license function. We have already covered how it works. And in the previous example, I showed you how easy it was to actually replace that instruction with the reverse one. And right now, we just want to check if that instruction or any instruction from above hasn't changed. We can do it just by enumerating all of those memory addresses and verifying if those instructions hasn't changed there. And it's actually super easy to do on your own. You can just create a for loop and start from the address which points to the beginning of the function, and then iterate until the end of that function. And for each address, you just get the opcode. So opcode, it is just the binary representation of the instruction. So each instruction has unique opcode. And then we can just create a hash out of it. We could just easily add all of the opcodes to our hash. And at the end of the loop, I mean, once we are done with the loop, we can just compare that hash with some magic value that you would compute during the compilation time. But we don't need to constrain ourselves to only a small function. We can do the same for the whole binary. Or on Android, we can, for example, hash the whole classes.dex. Well, we should also look out for swizzled methods. So a swizzled method is a method for which the function pointer was changed. And if we try to invoke that function, the fake function will be invoked instead. And I recommend actually reading more about it on a post from my colleagues from Guardsquare. They describe it really well, how it works. And in there, you can also find some solutions for Android case. Okay, so right now let's talk about walking through walls. that I promised to show you in the beginning of the webinar. So everything here starts from symbols. So a symbol is just a name of a class or a function or a variable inside our application. And we can dump all of those symbols from an application. And in case of Among Us, we actually dumped like symbols that described class. So there was a class which name was player control, and it had die method. It also had revive method, set skin, and murder player. So here we just wanted to find a relevant function that we could invoke, and we can invoke a function in many ways. For example, on a jailbroken device, we can invoke any method we just need to attach to the application. If we don't implement application integrity, we can invoke also any function once we are attached with a debugger. We don't have code integrity, we can modify an app in a way that allows us to just invoke that function. So once we know that we can invoke function, we can just find a relevant function for us. So we found actually a tricky way to do it. We just come close to a wall, we invoke die method, we turn into a ghost, we go through the wall, and once we are on the right side of the wall, we just invoke revive. And that's how easy it is. And then we just switch back to being a normal human in a game, and we can just continue the game. And it also works in a multiplayer mode. We actually did the whole demo in the multiplayer mode. You can also go and try it yourself today. And if you remember the demo about bypassing payments, we invoked onTransactionSucceed there. And that method should be invoked after the successful payment. So we actually dumped all of the symbols from the application, and we found that method. At that time, we knew that that method is triggered after the successful payment, and that method probably removes all of the ads inside the application. So you should protect your symbols so no one knows, well, no one tries to actually find usage for them. And also a question that you can ask yourself, how many meaningful names do you have in your app? And how many of them an attacker can actually leverage to, for example, bypass your authorization screen or a payment screen or any other feature that you have in your app. So let's talk about protecting against that kind of attacks. So the protection against it is called obfuscation. And well, it's not only about hiding away variable names and method names or classes. It's in general about making it harder for an attacker to understand your code. But also it's also about encrypting sensitive strings, keys, or tokens inside your app. Also about making the control flow harder to understand for an attacker. So you remember our example with check license, there was only one if statement, and there was only one additional block in the control flow graph. So an attacker had an easy job just to, find the right spot to modify the instruction. But we can just make the control flow a way harder, so it would look like that. And that would be super hard for a reverse engineer to understand. Then we can also encrypt assets. Here you can, for example, want to encrypt your assets to surprise your customers, players, or users with a new features. So for example, you want to release a new feature in 1 month, but you already want your users to have that feature installed with a new version of your app, but you don't want it to be known by anyone. So, well, especially you don't want attackers to actually reveal that feature for your users. So the best way is to actually encrypt those assets. So all of it is called obfuscation. And if you don't implement the obfuscation, then it's just easier for an attacker to reverse your app statically, or even steal your whole IP from, like, well, let's say that you have a function that makes some changes to an image. It just adds a filter to an image. And it's your algorithm that you developed yourself. And an attacker could just find the right symbol inside your application. They could just extract the whole function and use on their own in their application. So remember to actually obfuscate your symbols and make it harder to understand for an attacker. Also, there are companies that actually focus only on reverse engineering your application to discover secret API, and then they just implement clients for them. So be aware that there are a lot of attackers just looking for your symbols or your API out there. Right now, I want to tell you about some protections for obfuscation that you can do on your own. But firstly, obfuscation is a bit counterproductive for developers. So in general, developers should write clear. It's totally about the opposite. It's about writing the code super complex so an attacker wouldn't understand anything. And well, that's why we actually need to have a compilation time solution, because then developers don't need to write a complex code, but everything can happen during the compilation. So let's start from symbols. For example, we can obfuscate symbols with ProGuard, which is a free tool from Guardsquare. You can just obfuscate your symbols with that one, so an attacker wouldn't be able to understand names of functions that you're actually using in your app. Then let's move to control flow obfuscation. Here, I don't know any free tool that allows you to obfuscate your control flow, but if you really want to make your code more complex, you can create, for example, a while loop statement and then add an if statement at the end. So the loop would invoke only once, it would iterate only once, and then put your sensitive code in there. And if you even want to make it more harder to understand, you can put in here a switch with a lot of cases. In that case, an attacker would have a lot of blocks in the control flow graph. Then let's talk about encrypting resources. Here you can do it quite easily with XORing your encrypted text with the key, and that would be enough. Just remember that to have more than only one key, because if you have just one key that is used for all of the strings or assets, it is super easy for an attacker to find just one key and then use it on all of the strings and assets you have. So here, it's worth to actually use a lot of keys and spread it around the application. So right now, let's talk about why each of those components matters and why you should implement them all to make your app secure. Let's start from the example, from the case when you don't implement your environment integrity. In that case, an attacker can easily bypass application integrity. So even if you check for your signature or your package name, it doesn't matter because an attacker doesn't need to resign the application after you. Because on a compromised system, the operating system doesn't validate the signature. It just runs any function without checking the signature. So those apps can be also found in third-party stores. Then let's talk about application integrity. If you don't implement that one, it requires only one extra step to imitate environment integrity, actually imitate the compromised system, because you can repackage an app in a way that allows to attach a debugger, and from that point onward, you can just invoke any function you really want or just scan the memory. Then let's talk about code integrity. If you don't implement code integrity, an attacker could just overwrite your protection code. So right now, we know how to write our protection code. We know we can check for Cydia, for Bash, or for Su, or for Magisk, but an attacker could just overwrite our protection code as we did with the check license if statement. That's why it's actually super important to remember about that component too. Then about obfuscation, if we don't implement that one, it's easier for an attacker to find relevant functions. So you know how easy it was to find unsuccessful payment or die and revive methods in Among Us. So here we know that we should implement all of those components, all of those guidelines to make our app secure. And before you actually go and implement those protections on your own with solutions from that webinar, for example, remember about a few things. So firstly, regularly update your protection code, because if you don't, you'll just give enough time for an attacker to understand your protections. So just after, I don't know, certain time, you should just change the places where you have your protection code, so an attacker would have it harder to understand it. Or also, if you have the same symbol names, then it would be also easier for an attacker to understand your code. That's why actually a compile time solution is handy here, because it can randomize and everything for you. Then you should also check whether your protections will work on new iOS and Android versions. Because right now your protection may work, but there is a new iOS version, like iOS 15, let's say, and then your protection may not work. Or even what's more worse, your protection may trigger a false positive. And in that case, the application could, for example, crash on your customers' devices. So make sure to regularly update your protections so your customers won't get into crashes. So that would be it for that presentation. And now I'm happy to pick up some questions from the QA section. Thank you.
Awesome. Thank you, Jan, for that incredible presentation. As he mentioned, attendees, please go ahead and ask questions in the questions panel, and we'll go ahead and get to them. And we've got one that we're going to start with right now, and that reads, what if my app gets uploaded to a third-party store? How can I protect it then?
Well, in that case, it really depends on the application, I believe. Always you can write an official complaint to the third-party store and say that, hey, please take down my application, but I believe it won't work in most cases. So I believe that mostly that version of the application will remain hacked and be available for anyone to download. But anything that comes to my mind is that you can just change all of the backend endpoints that you are using right now. So the application couldn't connect with the server, but many times attackers just caches the responses from the server, so they even don't need to communicate with it. But I believe that you should just remember to implement your runtime protections in the new version, so it won't happen again. hope it answers the question.
Yeah, that makes sense. It definitely answered the question. And we have another attendee, Roman, who's wondering, could customized control flow integrity be leveraged against functions being called randomly?
Could you repeat that one?
Yep. He is wondering, could customized control flow integrity be leveraged against functions being called randomly?
Well, for sure it can. If we randomize the control flow, then some functions could depend on the other. So before we actually unlock certain features, we might get into crash away faster. So for sure, it brings big value to the whole security of the app.
Good to know. Another question someone is wondering is it illegal to scan memory and quote unquote steal those diamonds using the technique you showed?
Well, I'm not sure if I'm the right person to say if it's legal or not. For sure, it happens out there. I just wanted to actually wake your awareness that it's possible and that you should protect your applications against it. If it's legal, I believe it's not, but it's just happening all the time. So better protect your app.
And then going off of that, is that trick something that is easily detected as an app developer? Like, is there an easy way to do this without requiring back-end validation?
So, well, if you validate that variable with a backend, that would be the best idea to do it. But in many cases, you are not able to track those values because many games are happening in the runtime. They are just happening, well, every milliseconds matter because you are competing with others. So you could actually need to just keep some variables inside your memory. And in that case, you just need to protect it on your client side. So, well, nice way. Well, firstly, you should implement environment integrity and application integrity to fight with those. But if you are looking for something even better, you could encrypt that value. So even if you scan the memory, you won't find the value you're looking for because it would be encrypted. And once you use it or you want to modify it, you just decrypt it for a second, you modify it or read it, and then you encrypt it back.
Awesome. And then kind of along the same lines, asking about the bypassing of payments method. Would that method not be easily defeated by just inlining these kinds of functions?
Well, if we inline a function, then, well, firstly, we cannot inline everything. There are some handlers that we just need to put our function name into. So, for example, when the successful payment screen is done, then we invoke some function, and we can't really inline there everything. We just need to pass the function that will be actually invoked. So we can't always inline stuff. But even if you find a way to inline that one, an attacker could just jump into a certain place in the code that would probably trigger some crash later on, but we could get into the point where we already have every ad or some feature unlocked. So it's for sure, it's handy to inline that stuff. It's not always possible and still could be defeated.
Okay, that's good insight. Another attendee is wondering if Frida wasn't available, which other tools would you be recommending value beyond just renaming identifiers?
So, well, if the Frida wouldn't be available, if the Frida wasn't available, I think I would go for LLDB. because, well, it's already built in, for example, in Xcode. So if you're a developer and you actually work with Xcode on daily basis, you know LLDB pretty well. You can just attach your Xcode project into an application and then use the same commands as you used during the debugging. So for sure, LLDB. Then apart from LLDB, nothing comes to my mind. But well, Frida is for sure one of the most popular frameworks out there. Hard to live without that one. Okay, do we have something more?
Yes, we have about 2 more questions for you, I believe. One of those is, do you need to understand assembly to find the code to modify or hack a game?
So not always. Well, as I have shown before, we can just look at the control flow graph and it shows where is the if statement. So if we can see that a block branches into 2 different blocks, it means that there is probably an if statement. And we just should look at that few instructions before, and we should just focus on them. And they are enough to, well, in most cases, it's enough to just replace just that function to make it work. And those functions are in most cases TBZ, which we just check some value. They are just like if statements or in the developer world. So in many cases you don't, but for sure, if an app is complex, you need to know assembly a bit better or the Java bytecode.
Okay, that's interesting. And then our last question that we have for you today is, how widely used are those third-party app stores? The attendee knows that Apple has quite a closed ecosystem, but is it really easy for anyone to access and use those stores?
Well, I think I can show you one thing on the slide here. So one of the slides, yeah, exactly that one. We can see how many downloads each application had. For example, for Plants vs. Zombies, there was 162,000 downloads, then 100,000 for Bloons and 50 for Duolingo. So I would say the scale is big. Well, probably depends on the application, but remember that those downloads that you can see here, here, or here, they are only for iOS and only for iGameGAT. There are more third-party stores like that, and for sure more on Android than on iOS. So those numbers could be way, way bigger.
Nice. Okay, so it looks like we're about out of time. So with that, DZone would like to thank you, Jan, for a phenomenal presentation. DZone would also like to thank Guardsquare for providing the audience with a great webinar. Lastly, thank you to all of our attendees today. We hope you learned something new that will help you in your developer career, and we hope you have a great day.
Thank you.